Good morning, guys. Today we're going to be talking about motion and speed. So speed is the distance an object travels per unit of time. To calculate speed, you're going to do distance divided by time. Distance is in meters, time is in seconds. So the units for speed are meters per second. So we have two different categories for speed. You can have average speed, which is the total distance traveled by the total time taken. And instantaneous speed is the apparent speed at any moment, such as on the speedometer, which is what you see in the car. Speed determined for very short time intervals is called the instantaneous speed. And the equation here, distance traveled divided by a very short time. So it could be like a second. So here you have the average speed of the car. So it went a distance of 5 kilometers and divided by the time that you see up here, which is 0.20 hours. So you do 5 kilometers divided by 0.2 hours and you get 25 kilometers per hour. And let's look at our first example. A snail takes 5 seconds to crawl across the ruler. Distance was that the snail traveled is 7 centimeters. So if you want to find the speed of the snail, you do distance, which is 7 centimeters, divided by the time, which is 5 seconds. So because we have to do it in meters, remember speed is in meters divided by the time in seconds. So you have centimeters converted to meters equals 0.07 meters. And then you divide it by the 5 seconds and you get your answer. So the speed of the snail that was crawling across the ruler was 0.014 meters per second. Okay, next example, we have a car that drives 250 meters in 1 minute. So calculate the speed. You do distance divided by time. In this case, right, the distance is 250 meters and you divide it by 1 minute. And you know that in 1 minute you have 60 seconds. So you do 250 meters divided by 60 seconds. And you get a speed of 4.17 meters per second. Okay, this is a problem that you're going to be completing as part of your notes. And now I'm going to be checking for if you did it right or not once you turn those in. So let's say you drove a car from New York to Boston. The distance by road is roughly 300 kilometers. If the trip takes 4 hours, what was your speed? Remember that you're going to take this kilometers right here and you're going to convert those to meters. And you gotta take this 4 hours and convert it to seconds. So before you solve for speed, which is distance divided by time, you need to make sure that you have meters here and seconds here. So convert those kilometers to meters and convert those hours to seconds. You can go ahead and pause the video, solve this problem, and then you're gonna continue. Okay, so from the formula for speed, you can find speed, which is distance divided by time, or you can find time, which is distance divided by speed. These are the different variations of the same equation, right? Or you want to find distance, you do speed times time. Make sure you write this down on your notes. These are the different variations of the speed equation. So you can move the different variables to find whatever is your unknown. Okay, now we're going to talk about velocity. So sometimes knowing the speed is not enough, right? For example, sailors must know the speed and direction their boat is traveling in. So velocity is a description of both the speed and the direction. So that's the difference between the speed and velocity, right? So velocity is a combination of both the speed and the direction. For example, a sailboat is traveling at, I can't see that. Okay. To calculate the velocity, you're going to do the displacement divided by the time. Remember that displacement is the change in movement, right? So you're always going to do the final minus the initial. And that is divided by the time. So wherever the thing, for example, the boat ended at, minus where it started at. And if it's just sometimes, a lot of times, the initial time is 0 minus the final time. So you're going to do final minus initial divided by time. So let's go back to our friend the ant. So the ant is traveling. It started in 0, ended up 5, and then back to 3. And you have the time to be 5 seconds. So if you are going to, what was the distance traveled by the ant? So you went 1, 2, 3, 4, 5, and then it went back 6, 7. So the distance traveled, you would say, is 7 centimeters, right? Now, if you want to know the displacement, remember that the displacement is final minus initial. So the ant started right here in 3. So displacement will be the change in x. So it ended in 3 centimeters minus the starting point, which was 0, 0 centimeters. And that's how you get the positive 3 centimeters. Okay, for average speed, you're going to do, remember, the distance traveled divided by the time. So 7 centimeters was the distance traveled, and the time was 5 seconds. So 7 centimeters divided by 5 seconds gives you 1.4 centimeters per second. Now, if you wanted to calculate velocity, you're going to do the displacement, which we already calculated, 3 centimeters divided by the 5 seconds, and that gives you positive 0.6 centimeters per second. So this is combining everything we've learned: the distance, the displacement, the average speed, and average velocity. Now again, you're going to work this practice problem that's in your notes. Problem 1 says a man walks 7 kilometers in 2 hours and 2 kilometers in 1 hour. And he's just going in the same direction, right? So he started here in A. This is the start. And then he walked 7 kilometers. That's where he got to B. And that took him 2 hours. And then the next 2 kilometers took him 1 hour. Now I need you to calculate the average speed for the whole journey. And what is the man's average velocity for the whole journey? Okay, pause the video and go ahead and do that. Remember, when you're doing average speed, you're going to add those distances. So you're going to add the 7 kilometers plus the 2 kilometers divided by the sum of the time, right? So 2 hours plus the 1 hour. And then you divide those two and you're gonna get your speed, and it's gonna be kilometers per hour. Same thing for velocity. Calculate the displacement, and then you're gonna divide it by the time of the whole journey. Problem 2. Go ahead and pause the video to complete problems 1 and 2. This is similar to your previous problem. If you have any questions, you can always email me or join your class office hours and I can help you.